Hi everyone, welcome back to the channel. I am Samath and I make programming and DSA concepts simple for beginners. Today we will explore binary search, an efficient algorithm for finding elements in sorted data. If you are new here, don't forget to check out my previous video on linear search, where I explained how to search in unsorted data step by step. The link is in the description and at the top right corner of the screen. Binary search is like looking for a word in a dictionary. You don't start from the first page, you go straight to the middle, decide which half to focus on, and repeat the process until you find the word. This method is fast because it eliminates half the possibilities in every step. I have here a simple code on Java where I returned binary search. I will explain you every line of code, and here my goal is we want to find a specific number called target in a sorted list of numbers. If we find the number, we will return its position or an index. If it's not in the list, we will return -1. And how does the algorithm work? Instead of checking each number one by one, like in linear search, binary search divides the list into two parts and focuses only on the part where the number could be. This makes it much faster. Now here I have initialized two variables called low and high. Here int low is equals to 0 and int high is equals to array dot length -1. And low is the index of the first number in the list, and we call it as a position as 0. High is the index of the last number in the list. Length of the array -1. Now here I have initialized one while loop while low less than or equal to high. This loop keeps running as long as there are numbers left to check. If low becomes greater than high, it means the number is not in the list. Now here we are finding middle index. Int mid it is a variable and low plus high minus low divided by 2. This calculates the middle index of the part of the list we are searching. For example, if low is equals to 0 and high is equals to 6, then the answer will be mid is equals to 3. Here 3 will be initialized to mid value. Now here we are checking the array of mid is equal to target. My target value is 10 and array of mid is we have found as 4 or 3. It finds in the array where in this array it will find uh, the mid value and the targeted value. If it is equal, then it will return the mid value. If it is not, then it moves to else if value. Here mid array of mid value is 8 and target value is 10. Now this is array of mid is 8 and 8 is less than 10. That's actually absolutely correct. So then low is equals to mid plus 1. Here mid value we have taken as 8, right? 0, 1, 2, 3. 3 plus 1, that is 4. Now low is equals to 4. That's it. And if this also condition is not true in this array, then it moves to else value. In else, high is equals to mid minus 1. If both of these conditions are not true, then it moves to this condition. Else high is equals to mid minus 1. Then the target must be in the left half of the list. So we ignore the right half by moving high to mid minus 1. Else, if we don't find anything, then we return -1. If the loop ends and we haven't found the number, we return -1 to indicate it's not in the list. Let me walk you through an example. Let's say we have an array of size 7 where I have taken the same example from the code itself. 2, 4, 6, 8, 10, 12, 14 is the elements found in an array, elements stored in an array. So here my low value is 0 initially, and high high value is 6. Array dot length -1 will be 6. And firstly we find mid value now. Now mid is equals to 0 plus 6 divided by 2 is equals to 3. Now let's write an index here: 0, 1, 2, 3, 4, 5, 6. Now I got a mid value as 3, third index. The value will be 8. Now let's write array of mid value is equals to 8. Since the target value we have as 10, now first condition what we saw is array of mid less than target. This condition satisfied because see, array of mid is 8 is is less than target value. Now we initialize low value as 4 because mid plus 1. Now mid value is 3. 3 plus 1 will be 4. Now low is equals to 4 and high is equals to 6. Now left part, that is these parts, will be ignored and only checks for these values. We ignore these value and we take only these three values now. So low is equals to 4 and high is equals to 6. Now in this three elements we have to find a mid value again. Since we have a while loop, we have to check again and again until we find an element. Now mid, now low is equals to 4. Since low is equals to 4, so let's write 4 plus 6 divided by 2 is equals to 5. Now this will be a mid value. Now array of mid will be 12. Since 10 is less than 12, we ignore the right half. Now as you can see, these two conditions will not be satisfied. Now we have to check for this condition. So we have to ignore the right half now. So we have to ignore this right half. So here again low will be 4, high will be 4 because here high is equals to 6. According to the code what we have here, high is equals to mid minus 1. That is mid value is 5. 5 minus 1 will be 4. So low is equals to 4 and high is equals to 4. In this again we have to find a mid value. Mid value is equals to 4 plus 4 divided by 2 is equals to, we get 4. In this array of, we move array of mid is, as you can see here, fourth element is 10. So array of mid value will be 10. That's it. We have found a answer or an element in fourth index. We return 4 as the position of 10 in the array. I hope you have understood this explanation. This is how the code works. And as if you think why this binary search is faster, instead of checking every number like in linear search, uh, I have explained how linear search works actually, and it checks every element one by one. Instead of checking like that, binary search skips half the numbers in each step. For a list of 1000 numbers, binary search only needs about 10 steps to find the target. And that's how binary search works. If you found this helpful, make sure to check out my previous video on linear search. The link is in the description and on the screen now. Don't forget to like, share and subscribe to the channel for more beginner friendly DSA content. See you in the next video and thanks for watching.